Okay, hopefully this is live now, but I'm still not completely sure. Okay, alright, looks like it's live. Okay, so welcome to another live stream. In this live stream, it'll be fairly short today. I'll be doing a couple of problems, starting with this one on the screen right now. So this problem says, part A, simplify the square root of A plus the square root of B times the square root of A, take the square root of B, and then hence show that 1 over root 1 plus root 2 plus 1 over root 2 plus root 3 plus 1 over root 3 plus root 4, etc. all the way up to 1 over root 24 plus root 25 equals 4. Hi Arvind, welcome. Okay, so clearly this part A is trying to give us a clue about part B, so let's go ahead and do part A first. So we've got the square root of A plus the square root of B multiplied by the square root of A take the square root of B. Okay, so let's expand these out as we would normally expand double brackets using FOIL. So multiply the first terms. The square root of A times the square root of A is just A. The square root of A times negative the square root of B is the square root of A, negative square root A square root B. Positive square root B multiplied by square root A is positive square root A square root B. And then the last terms, the square root of B times the square root of B, negative square root of B is negative B. Okay. Then we can simplify further because in here, these inner terms, they are like terms, right? I've got a square root A and a square root B in both. They are like terms. And, well, this is essentially saying I've got negative 1 lots of this thing plus 1 lot of that thing. So negative 1 plus 1, they cancel out, right? That's 0. So these two terms in the middle, they're going to cancel out, and I'm left with A take B. Okay, welcome Flavia. This is higher. That is the difference of two squares. Awesome, welcome. Blue Snow, Lily, hi, hello. Okay, so how's that going to help us for part B? That's the question. Alright, so let's just write out some of these. So we've got 1 over square root 1 plus square root 2 plus 1 over square root 2 plus square root 3, and I might write out a few more, square root 3 plus square root 4. I'm terrible at writing 3's on here, I don't know why. All the way up to 1 over square root of 24 plus square root of 25. And we want to show that equals 4. Hello Google account. That is a very descriptive name. Okay, well, what might you start with when you have expressions with square roots in the denominator? You would start by rationalizing the denominator, right? So we want to get rid of the square roots in the denominators of all of these. Well, let's just focus on this first term. How could I rationalize that denominator? Well, we would multiply by the negative of that thing. And we've just shown that in the first part, right? We had square root of something plus the square root of another thing. To turn that into a whole number without any square roots, we multiplied it by the square root of A take the square root of B. So for this one here, we could multiply it by square root of 1 take the square root of 2. And if I do that in the top and the bottom, or the numerator and denominator, then I'm multiplying by 1, and I haven't changed anything, so that's okay. I'm allowed to do that. I can multiply anything by 1 and it will still be the same thing. Okay, So what would we do for the second term here? We would multiply by square root of 2 plus square root of 3. Multiply that by square root of 2, take the square root of 3, over the square root of 2, take the square root of 3, and so on. I'll just write those two to start with. Okay. Hello, Repro. Difference of two squares. Sir, can I ask you a question on matrix? I can try to answer it. I can't guarantee. I haven't done matrices for a while, so I might not actually. Yeah, I probably can't help, but feel free to post it anyway. Okay, maybe you can see what might happen next. Well, remember we've already done this operation, right? Let's look at this denominator in this term here. Let's think of these as two brackets. I've got square root of 1 plus the square root of 2 multiplied by the square root of 1 take the square root of 2. Well, we just showed what that would be. We showed that that would be A take B. So the first number take the second number. That's what's going to be left in the denominator. What's in the numerator? I've got 1 multiplied by the square root of 1 take the square root of 2. That's just going to be the square root of 1 take the square root of 2 in the numerator. In the denominator, as we just said, that's going to be 1 take 2. Okay. Second term here. The same thing is going to happen in the denominator. Square root of 2 plus square root of 3 multiplied by the square root of 2 take the square root of 3. That's going to be 2 take 3. And I'll just say it again just to be clear. I really want you to see the connection between what we did in part A and what we're doing down here. So I don't have to do the whole thing out again. In the numerator, I'm left with the square root of 2 take the square root of 3. And without writing the third term here, maybe you can see what it actually would be without writing what I'm multiplying by in the third term. Maybe somebody could post what that third term would look like. Feel free to have a go at that. Okay, I'm just going to go ahead and do it. So this third term here, well, that's going to be the square root of 3 take the square root of 4 all over 3 take 4. What would the fifth term be? The fourth term be? That would be the square root of 4 take the square root of 5 over 4 take 5, and so on all the way up to the last term. What do you think this one would be here? Well, we'd be multiplying by the square root of 24 take the square root of 25 over the square root of 24 take the square root of 25. In the numerator, I'd be left with the square root of 24 take the square root of 25 all over 24 take 25. Okay, let's see. What next? What next? Well, let's look at the denominators. 1 take 2, what's that? 1 take 2, that's negative 1. 2 take 3, that's negative 1. 3 take 4, that's negative 1. So all of the denominators, they're going to all be negative 1s. All the way up to the last term, negative 1. What about the numerators? What do we have in here? Well, we could leave those as is for now, but maybe you can see what might happen next. And actually we're going to be able to simplify quite a bit more. So it's getting a bit messy, but hopefully it's still clear enough. Well, if we divide something by negative 1, what do you do to that expression? You just change the terms, right? This positive root 1 take root 2, that's going to become negative root 1 plus root 2. And then there's no longer a fraction, right? Next one, positive root 2 take root 3. If I divide by negative 1, that becomes negative root 2 plus root 3. Oh, I'm getting somebody saying it's not loading. It should still be okay. Alright, anyway, let's keep going. Just let me know if it cuts out. Okay, so now it's fine. Okay. So what was I saying? So we're dividing everything by -1. Root 3 divided by root 3 take root 4 divided by -1 would be -root 3 plus root 4. And then maybe you can see already what the next term would be without having to write it there. It would be negative root 4 plus root 5. Yeah, I'll just finish this one off. And so we could keep going all the way up to the last term here. That would be negative root 24 plus positive root 25. And if we look at all of these terms in the middle, we're going to be able to actually cancel all of them, aren't we? So positive root 2, take root 2, they cancel. Positive root 3, take root 3, they cancel. Positive root 4, take root 4, they cancel, and so on. And everything's going to cancel except for the negative root 1, the negative root 1, and the positive root 25. Negative root 1 is -1. Positive square root of 25 is positive 5. What are we left with? -1 plus 5 is 4. Okay, so there you go. That's quite a nice problem, I thought. It simplifies quite nicely. Now, a question you might have is, well, isn't the square root of 25 positive or -5? But the thing, but the reason we're not including that -5 is because they specify in the question. When they tell you it's a positive root 1, that's telling you the answer is a positive. They would have to specify in the question it's a positive or negative root 1 in there. At least that's how I understood it. So if they want you to consider all of those possibilities, so down here, if they want you to consider positive or negative root 1 and positive or negative root 25, they'd have to specify that in the question. Okay, so there you go. That was sent in yesterday, so I thought I'd start off with that one. And Arvind said how to multiply matrix of order 1, 3 and matrix of order 3, 3. I vaguely remember that. So I don't even remember how to draw the matrices. So yeah, I don't even remember what symbols to use in these. Wasn't it like I, J, K, 1, and then I, 2, J, 2, K, 2, so on, something like that? Or just 1, 2, 3? Okay. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, there's definitely a method to do that, and I don't remember what it is. Hello, Alita, welcome. It's not. I don't remember it being too difficult. It's just that I haven't done it for so long that I can't. I mean, when I say not too difficult, I mean it's yeah, I don't know what I mean. But I think there's a clear method. That's, I guess, my point. There is a clear method to do this. Well, I guess you could just think, if you have two 1x2 matrices, you just multiply across, right? Yeah. Maybe you have to review some of that later. Y equals 2 to the power x, express 2 to the power x, take 1 in terms of y. Given that y equals 2 to the power x, express 2 to the power x, take 1 in terms of y. Well, I guess you could take 1 from both sides. And there are 2 possible values for y. Oh, y equals 2 to the power x. Oh, okay. Not sure about that one either. I don't think I really fully understand the question, to be honest. AS Mechanics 2019 paper. Yeah. If you email me, then I'll get back to you later after the live stream. Okay, Vincent, maybe if you could be a little bit clearer, or I'm not. Oh, y take 1 is the answer. Okay. Alright. This is a question I put up yesterday, and I kind of left it because I thought, well, I thought I could just maybe give you a chance to think about it. So there's a sequence of numbers, find the rule. And I didn't give a hint yesterday, so I'll give a hint today. It's a Fibonacci type sequence. So there's the hint. No, I do not have a PhD. I wish I had studied PhD, kind of. And I guess I could still go back and study one. Which is a definite possibility. I would like to study further, but yeah, I'm not sure at the moment yet what my plans are. Alright, what to do? Is anyone having a go at this? Vincent Tran says, where can I email you? Here's my email. explain2@gmail.com. So yeah, I did a live stream yesterday. Obviously I'm live streaming today. This is kind of part of my plan to just sort of I don't know, just sort of be more involved on YouTube. I'm trying to make more videos and get more done. As you can tell, yesterday's live stream I was mainly just kind of yeah, I didn't have much planned. I was playing some games for part of it, and we did some problems that people had. There was a really interesting combinatrix problem that I might do a video on later, but yeah, I'm kind of just trying to live stream, even though I don't fully have that all planned out at this stage, and trying to get into a habit of doing it, because I have this time in the day, about an hour or two most days where I do have that opportunity to live stream, and I'm just trying to go ahead and do it rather than just think about it. So yeah, even if well, basically I'm saying, yeah, there's not much planned at this stage, but hopefully in the future there will be more planned, and there'll be more, like, it'll be more of a lesson type thing. A video on matrices? Yeah, I could try to do that. That would be good revision for me as well, actually. Although 5822, is that the next one? Yes, I think that is the next one. Christopher, do you have the rule? I think someone has cracked it. This sequence of numbers actually came up in the problem, one of the problems I did in a recent video, that International Math Olympiad problem. This is a sequence of solutions to that equation, and I don't know, I was just interested to kind of, you know, I was interested as to where this sequence came from, why it was in that problem, you know, why these were the solutions to that equation. If you're not sure what I'm talking about, check out my video. I think I titled it "I Went Insane Solving This Problem." It's an International Math Olympiad question from 1988, so-called the legendary question 6. Christopher is not sharing how he got the next number. He's keeping it tight to his chest. Does anybody else have the rule for this sequence? How are you producing that next number? Multiplying the number by 4 and deducting the previous number. Awesome. Well, that's exactly it. That's exactly it. If you actually wanted the equation for the nth term, it's quite a bit more complicated. It's like you know, the Fibonacci sequence is simple to produce, right? It's 0. Sometimes it's written 0 0, but you can just start as 0 1 1 2 3 5 8 13 and so on. You're just adding the two previous terms, so that's easy to state, right? Just add the previous two terms. But the actual rule for that looks really complicated. It involves the golden ratio, and things like that. So the nth term for Fibonacci type sequences always looks quite complicated, but to produce the next term is quite easy. So as Christopher says, exactly right, you multiply starting with 0, and actually the first two terms are given to you. So to produce the next one, you multiply the 2 by 4, take 0 is 8, multiply 8 by 4 is 32, take 2 is 30, multiply 30 by 4, take 8 is 112, multiply 112 by 4, take 30, 418, and so on. So the rule here, if you wanted to find the next term, a sub n, it's a sub n, sorry, you would write this as 4a sub n take 1, take a sub n take 2. So that's how you might write it. And I am not going to write down the nth term formula because, well, firstly I don't remember it, but secondly I don't know, well, I guess it's helpful if you want to see what it is, but I think it's much easier just to think about it in terms of how to get the next term. Marcus says he also got 5,822 and this came up in a Math Olympiad. Oh, this actual question came up? Oh, that's interesting. Yeah. So that is solutions to this equation. I'll try to remember what it is. It was a plus b over ab plus 1 equals 4. Yeah, so no, that's they're the integer solutions to that equation, I believe. Mess E. No, I don't live in Australia. I am clearly from Australia, but not currently living there. Okay. I have about 10 more minutes. Multiply by 4 and subtract the previous one. Awesome. What could I do? Well, yesterday I was actually talking about playing some chess. So why not give that a go? If anyone has any more maths questions, by the way, feel free to post them. Possibly that's more interesting than me playing games. Mess E. Oh, so you're from Australia? Yeah, Arvin, feel free to ask a question. Year 10. So I studied maths all the way through to year 12. I did, yeah, both of them. So specialist and I'm not sure what it's called now. When I was at school, it was called Math Studies. I forget what it's called now. But yeah, I did both of those through to year 12. And I really enjoyed it. So yeah, I'd recommend that if you are interested in mathematics. Definitely. It's a good option. It gives you methods. I think it's called methods now. Yeah. Gives you a lot of opportunities at university. Hard. I mean, yeah, it's hard to kind of give an idea about that because I enjoy mathematics, so I spent quite a bit of time studying it just because I wanted to. But it wasn't like I wasn't studying it non-stop all the time. It was just like, you know, your regular 20-30 minutes of homework every day. Make sure you get your homework done, and then that's it. And I was able to manage. And the good thing about doing those higher level math subjects is that your grades are usually boosted at the end. So if you get like a 17 or 18, it might boost up to a 19 or even 20. Whereas if you study something like you know, something in the social sciences, they often grade them down. So there's a reason that you might want to study those. Oh, okay, you haven't got your notebook, so ask me next time. Yeah, sure. Hopefully I'll be doing one tomorrow as well. But yeah, I'd definitely recommend studying mathematics, being that I have a mathematics YouTube channel. I guess that's always what I'm going to say. Yeah, sure. One last question. Of course. Oh. I apologize, Red Hood. Awesome to hear, Arvind. Simplify fully. 4y plus 2y cubed multiplied by 2y to the power of negative half plus y to the power of 3 on 2. Chris says, I have to say, YouTube channel is really good. Keep up the good work, enjoying streaming during the lockdown in sunny London. Thank you so much. That's really nice. So I'm going to write these a little bit differently to start with. Well, don't overdo it, Arvind, but yeah, I think it's always good to do a bit of studies in the break. I think just to keep your mind active, and you can go back to school a bit more prepared. Divide sign. Oh, dividing. Okay. And y to the 3 on 2 is the square root of y cubed. Let's see. Can I do maths A-level with a 6? I think so. I'm pretty sure most 6 forms accept a 6, and I think it depends on the 6th form. But yeah, I'm pretty sure a 6 is fine for A-levels. Thanks, Arvind. Okay, so I could rationalize that denominator. Not sure that helps though. What else? I'll combine those two. I could have also factorized these. I don't know. Combine these together, this would be 2 root y plus root y cubed, oops, y root y cubed on y. Okay. And then flip and multiply, so this would be 4y squared plus 2y to the power 4 on 2 root y plus y root y cubed. This is way more complicated than I thought it would be. Oh, okay. So if you factorize a root y out, you're left with root y squared, which is this y. So then that becomes y squared. So then you're left with 2y squared. I feel like there's a way simpler way of doing this. Was there? Yeah, probably. Anyways, well, actually, you could rationalize that denominator. Oh yeah. 2 y root y. Whoops. Wait. Yeah, 2y root y. Yeah, 2y to the power of 1.5, which was what this would be, 2y to the 3 on 2. There must be a way easier way of doing that. I did it the really long way. But yeah, 2y to the power of 3 on 2. So, tips on problem solving. Yeah, that's a hard one. Actually, if you follow 3 Blue 1 Brown, here's another YouTube channel. I'm sure most of you have seen 3 Blue 1 Brown, but if you haven't, it's another mathematics YouTube channel. He recently did I think about a 2-hour live stream all about problem solving. It's actually really helpful. He goes through a bunch of examples and he gives a list of 9 points. 9 points that can help you with your problem solving. Yeah, it was really good. So check out 3 Blue 1 Brown. I think it was his last live stream. I think it's titled something like tips for problem solving. So you could start there, messy. So I guess let's just review the steps I did. Although there must be a simpler way. So I wrote that as a fraction. wrote the square roots, rationalize that denominator, combine those terms in the denominator, flipped and multiplied that fraction, factorized the square root of y out, and then I had those 2 plus y squared and they cancelled, and then from there I think it's fairly simple. I'll just search on YouTube 3 blue 1 brown. 3 blue 1 brown. Sorry, just 1L. Yeah, search on YouTube 3 blue 1 brown, and I think it's one of his last videos. It's tips on problem solving. If you're in year 10, some of it may be, I think it should still be accessible to you, although he does go like into fairly complicated stuff at times, but I think a lot of it is quite good for if you're in year 10. Desaji, I think, yeah, this would be an A-level question. This one, simplify that expression. That would probably be A-level. Okay. What's the time? 3. Yeah, I have to go. As I said, this would be a bit of a shorter live stream today. Thank you for your questions, and thanks for tuning in. This is really fun. I'm really enjoying it. Did you find it messy? And hopefully I'll see you tomorrow around 1:30, something like that. But we will see. Alright, thanks for tuning in. See you next time.